Hello students, welcome ulit sa online tutorial natin. So, continue tayo for problem number 16. So, actually, number 16, 17, and all the other problems no, with regards to beams, you can actually solve this one easily using the Excel file that I have provided. Check muna natin ha. Yan yung Excel file natin. So, anyway, let's try to check now if ever we can still use this one in answering the problem. Sige. Yeah. So a simply supported beam daw is reinforced with with 4 28 mm at the bottom and 2 28 mm at the top. Sandali, medyo palakyan natin yung solution. Yan. And then steel covering daw to center is 70 mm and at the top and at the bottom. Now the beam daw has a total depth of 400 and a width na 30 mm. FC prime is 30, Fy is 415. So question, determine daw the depth of compression block, the design strength of the beam, and a live load daw at midspan. So anyway, we have here the detailed solution. Now let's try to use daw our software to check no if ever tama ba or mali yung answer natin. So based on the problem given, we have 428 at the bottom and 228 at the top. So we can assume no that since this is simply supported, yung 428 will be yung AS, which is for tension, and then yung dalawang 28 will be in compression. So input na lang agad natin. So that's 428 and then 228 din ba? Tama ba? 28 di ba? Tama. And then covering is 70. So anyway, FC prime muna. Ano yung FC prime? That's 30. Ang Fy is 415. And then ang D prime, ang covering is 70. Walang effective depth D. Now, notice sa given problem natin, ito ba yun? Yan. Notice sa given problem, walang effective depth na sinabi, but rather sinabi yung total depth. So, kayo na lang ang bahalang mag-subtract ha. So, that's 40 minus 70, that's obviously 330. So, meaning, ang effective depth natin sa Excel file will be 330. And then, ang beam width, I think sinabi din naman sa problem. Ano ba yung beam width? 300 din. Okay? So, expect, no? This is actually 300. Yeah. So, we have our answer here. Check na natin kung same ba tayo ng sagot sa mathcad natin. Tama no? Same lang. Kung mapapansin nyo, ang sagot dyan is 253.7 while our answer is actually tama. 253.737 then. Anyway, I'll try to explain the flow of the solution ha. I'll try to explain the flow of the solution. Sige. Ay, sorry. Yan pala. So first, of course, we need to solve for the total area of steel sa tension and then total area of steel sa compression. By the way, that's AS for tension, AS prime for compression. And then you have the D prime, yung total height, yung width B, FC prime, Fy, beta. Notice, since our FC prime is greater than 28, beta will not be equal to 0.85. Anyway, you have your equation here. Again, if FC prime is greater than 28, then the beta is this value, hindi yan pwedeng exactly 0.85. And then you have your effective depth D, basically yung total height na 400 minus the minus the D prime na 70, you have the effective depth na 330. So the first thing that you need to do is to check if we will analyze this one is a doubly reinforced or singly reinforced. Again, bakit ganun sir na obvious naman sir na doubly yan kasi obvious naman sir no na doubly yan kasi may top bars, may bottom bars. Again, sa board exam kasi, what usually, ang ginagawa ni Parceris mo is, you need to check kung ang rho is actually greater than the rho max. No? Now, ang rho is actually considering na ang AS purely yung sa bottom bars lang. And then, if you notice na, mas malaki yung rho kaysa sa rho max, then ibig sabihin, we will analyze this one as doubly reinforced. But if ang rho is less than rho max, then this is actually, if ang rho is greater than rho max, if ang rho is greater than rho max, doubly, while if ang rho is less than rho max, then that's singly. And then baka magtatanong, sir, why do we need to analyze this one as a singly reinforced? Kung doubly reinforced man yan, I think I actually doubly reinforced kasi may top bars, may bottom bars. Now, why is it singly reinforced? Again, I think I explained this one sa mga previous problem, no? Ang idea niyan is, we will design the beam. Actually, the beam is supposedly designed as singly reinforced. However, there is a top bar. Kasi nga, number one is for the stirrups, di ba? Kailangan kasing meron tayong parang dun makasabit yung stirrups ba. And then number 2 is for practicality din. Now, notice, usually pag simple beam, or let's just say most of the beams naman is fixed naman, no? So, pag fixed beam, di ba, meron ganyan, ganyan, and then pag itong beam. So, sa fixed beam kasi, negative moment dito, positive moment sa gitna, and then negative moment sa mga ends. So, what will happen, your supports, or yung tension steel, should be sa gitna, must be sa bottom, and then dito lang sa bottom, sorry, yan. And then, for the supports, nandito sa top. And then, dati kasi, di ba, may bending yan, para manabibend yan. However, for practicality, I think it's best no to, kaya, di ba sa practice kasi, hindi na yung, wala na yung mga bend-bend, no? So, ang ginagawa is, diretso na yan, straight, ha? Yan, straight na yan. So, kaya, although singly reinforced, and actually, yung section is dalawa yung rebar. So, kaya you still need to check ha, if ever that is singly reinforced or doubly reinforced. Sige, so balik tayo dito. Yan. So, first, check natin if doubly reinforced bar singly. Notice, ang rho actual is AS over BD, which is 0.025, while ang rho max is 0.85 FC prime over FY beta, 3 over 8. Again, this is 3 over 8 for the new NCP. So, we have ang rho max na 0.019. So, but again I'll be honest, yung rho max supposedly is 3 over 7 for NCP 2015.004 ang strain. However, sa inyo, it's best to assume rho max to be 3 over 8. Okay? And then I believe ito din yung ginagamit ng instructor ninyo. Kasi if our rho max is 0.004, we will have a problem sa flexion, yung bang reduction factor sa flexion, which is yung phi. Kasi pag ang strain hindi umabot ng 0.005, the phi is not actually equal to 0.9 din. Kaya dalawa na yung ano. And then, sa recent din na ACI, although hindi pa adapted ng NSCP, sa recent na ACI, 3 over 8 na yan. Okay? 0.005 na ang strain sa steel, hindi na 0.004. So, I hope okay tayo kung bakit 3 over 8 yung ginamit ko. Anyway, since rho max is less than the actual rho, meaning this is actually a doubly reinforced beam, we will analyze this one as doubly reinforced. First is we need to have assumptions for doubly reinforced. So, ang ginawa natin dito, first, tingnan nyo, I assume that the compression steel yields. What will happen if I assume that the compression steel yields? Kung mag-yield ang compression steel, since this is doubly reinforced, then my equilibrium equation, summation of forces horizontal, di ba? Equilibrium yan. Meaning, the compression from the concrete plus the compression from the steel, kasi dalawa kasi yung compression, concrete at saka yung steel, kasi meron tayong compression bars, must be equal to the AS times FY. AS times FY or yung tension steel. Okay. Now, you might be wondering, sir, bakit you only assume the compression steel to yield? How about the tension steel? Now, don't worry. Actually, parang automatic na, no? Now, we assume that the tension steel yield kasi pag doubly reinforced, almost always tension steel yields. However, yung compression steel, may chance na hindi mag-yield, may chance na mag-yield. But anyway, dito I assume na nag-yield, so we will use Fy for both stresses sa steel. Notice, ang stress sa steel for, the AS prime is Fy. The same is true for AS Fy then. And then we actually solve the value of the concrete compression block, no? Which is A. Now, you might be wondering, sir, bakit yan yung ginawa mo? Now, there are many ways to solve this problem, but it's best not to follow a certain step. I believe, binigay ko na yung certain step na yan. Sandali. I think may binigay ako na separate lecture ata. Sandali, hanapin ko muna. Ito ata yun. Parang separate video and PDF. Diba? Sa steps for analysis yan. Diba? Yan o. So, ito yun. First, assume tayo na steel yields. If it does not yield, we will use this equation. And then just follow this step and then you can actually answer the problem. However, this is not the only way to solve the problem. May iba pa mga paraan to solve the problem. But, depende na sa inyo. But please, use this method kasi mas madaling ituro. In my case, mas madaling ituro. And I think mas madaling yung maintindihan yung actually, ito meron pang isang equation para dito to solve for P. Hindi ko pwedeng hindi niyo gamitin yung strain kasi you can multiply the whole equation by 200 di ba? 200 yung modulus of elasticity of steel. So instead this is strain, this will become Fs. But anyway, that's for later na lang yan. Balik tayo dito. Yan. So notice, I solved A kasi sa equation na to, only the concrete compression block is the unknown, which is 0.85 Fc prime AB. This is actually C1. C2 is actually S prime Fy. And then AS. All of these variables are given except for A. Now, nasolve ko ang A. Ang A is actually 66.8. You can use your calculator shift solve. After solving for A, you can now solve for C. Diba? C. Sorry. So, you can now solve for C. C is actually A over beta, which means C is 79.94. Now, kanina, we assume no, that the steel, we assume that the compression steel yields. Now, let's check kung tama ba yung assumption natin. Notice, although we assume that the compression steel yields, I always check if ever nag-yield ba yung tension steel. But obviously, nag-yield ninyo. 600 D minus C over C. By the way, this is the actual equation for the steel stress. So stress steel. Now, for tension, that's 600 D minus C over C. For compression, that's 600 C minus D prime over C. Notice, ang Fs for tension, actually, okay lang, nag-yield. Greater than, ano ba yung Fy natin? 415. Nag-yield. However, tingnan nyo yung Fs prime, hindi siya nag-yield. Meaning, mali pala yung sagot natin dito. So, bakit mali yung sagot mo? Diyan na, yes, hindi nag-yield. Yeah, again, mali yung sagot natin dito kasi we assume na nag-yield. Meaning, yung equation natin, we assume that to solve for A, Fs prime is Fy. But since hindi, we need to solve a new value of A. So, hindi pala nag-yield. Sorry, what yield? Sorry, did not yield na. Did not yield. Okay. Once na hindi yan nag-yield, kalimutan nyo lahat ng value ng A. Ibig sabihin, mali ito, mali yan, mali yan, mali yan, mali yan lahat. Maliban dito, of course, sa first tool. Mali yan. Kaya tingnan nyo sa software ko, kinalimutan ko lahat. Bakit? Kasi, yun nga, mali yung equation mo. So anyway, to solve for the new concrete compression block, based on the PDF that I have provided you, yung steps na binigay ko, ito pala. So, since hindi siya nag-yield, if steel did not yield, you can use this equation. Basically, this is just the same sa previous equation, except instead of using Fy for the Fs prime, we will use the actual value or actual equation of Fs prime, which is 600 C minus D prime over C. Now, the only problem is medyo mataas yung equation na to. And then, depending na siya on how you will actually fit this sa calculator, I suggest nyo, actually, kaya naman natin i-kasya to sa calculator. Check na natin, pwede bang i-kasya sa calculator. So, ang gagawin ko dito, I will actually store the values of 0.85 Fc prime. All of these are actually constant. By the way, you might be wondering, sir, di ba that's 0.85 Fc prime AB? Bakit naging beta C? Now, for the whole equation, I only want one unknown. Now, since ang Fs prime is a function of C, I will make A as a function of C para the whole equation, ang unknown is C na lang. Okay? So, pagkasyahin nyo yan sa calculator nyo. Now, one of the ways for all of this to be fitted no sa calculator niya para hindi magkulang is you can actually store the variables, 'di ba? For example, ang AS prime is stored niyo sa letter A dito sa calculator. Ano ba yung AS prime natin? Yan o, 2463 i-store niyo yan sa calculator. Ang AS i-store niyo sa calculator and then you can write this whole equation. Okay? And then you only have C as your unknown. Check na natin. 0.85 Fc prime. Ano ba yung Fc prime? 30. 0.85 Fc prime. Beta. Ano ba yung beta dito? 0.836. 0.836. By the way, may discrepancy ito ng count since I'm not using the actual value of beta. Medyo mataas pa yun. 836 something. 0.85 Fc prime. Ano yun? Beta. And then B. Ano yung B? 300 times 300. So, ito, since that is constant, I will store that one sa letter A. Lagay ko yan sa letter A. Okay? So, I think, pwede na ikasya natin ninyo. AX, kasi meron C sa first term, you know. Diba? AX plus, ano yung AS prime? Ano yung AS prime? 1231.504 times 600 D minus C over C. So, times 600. Ang D, ano yung D natin? Sa problem, that's 330. 330 D minus C over C. And then, ano pa ba? equal to, ano yun? Equal to ASFY. Ano yung AS? Balik tayo dito sa problem. AS is 2463.09. So, that's 2463. Sorry. 2463. And then, ang FY is, ano yung FY? 415. Okay, I think yan lang. And then, shift solve na. Now, take note ha, pag nag-shift solve kayo, of course, yung value ng A na store natin kanina, pag nag-shift solve kayo, give the calculator an idea of what is the answer. If you can see, your equation actually involves unknowns na nasa denominator. So, medyo matagal to. And then, this is actually a quadratic equation, so you will have two roots. Notice, meron nga tayong dalawang root using the software. So, to give your calculator an idea of what is the answer, just input a value from 100 to 200. Anyway, most probably, C will be that range man. So, I'll just put 100. Okay? And then, your calculator will actually give an answer closer to 100 instead of giving the negative root. However, I'm using an emulator, so kaya siguro medyo matagal dito. But sa inyo I believe you're using the actual calculator man. Hopefully, no? Medyo mabilis yung calculator niyo in solving for the unknown. May mali ba ako dito? 600. Oh, naku, mali. Mali yung nilagay ko. That's 600D minus C yung nilagay ko. Hindi D minus C, Fs prime pala, no? So, that's C minus D prime plus C, which is X minus, ano ba yung D prime natin? 70. So, shift solve. Yan. And then X is 100. Check natin. Oh, yan. We have C equal to 114.76, which is actually tama naman. 114.786 dito. Okay? Once nakuha mo na yung C, meaning, you can now solve for the actual stresses na. So, ito yung actual stresses natin, 1124 at saka 234. This time, tama na yung assumption mo no, na hindi nag-yield. Okay? So, kasi 234 is less than 415. Once nakuha mo na yan, actually, hindi yan yung tanong. Ang tinanong is the actual, yung capacity. Diretso na. MU is equals phi FC prime. Di ba? Meron tayo nito, phi, and then times 0.25 FC prime AB. This is actually C. Again, for this equation, baka magtaka kayo saan galing yan. Again, nandito pa din yan sa binigay ko na PDF file. You know, Mn1 plus Mn2, where Mn1 is actually C multiplied by D minus A over 2. And then Mn2 is actually S prime, Fs prime, D minus D prime. Okay, so I hope okay tayo dyan. And then, tayo dito. Yeah. Okay, now notice, ang phi na ginamit ko is 0.9, but supposedly, you still need to check, no? Kung 0.9 ba talaga. How do we check kung ang phi is 0.9? Kasi supposedly, it will move from 0.65 to 0.9. So, to check for this one, you just need to check ang Fs. Take note, if ang Fs is between the yield and the yield and the 1,000 na Fy, if Fs is between Fy and 1,000, meaning you cannot use 0.9, you need to use the certain equation. But anyway, Fs is greater than 1,000 man, you can use 0.9. Sige, so diretso lang. This is just actually for the units. Kaya divide natin by 10 to the power of 6. So you have your Mu equal to 253.73, which is actually the same lang, no? So nakuha natin sa Excel file natin. Anyway, after that, you can solve for P. How do we solve for P? Ano ba yung tinanong sa problem? Determine the live load at a mid-span in addition to a 20 kilonewton, including its weight, if it has a span of 6 meters. Again, basically, no, we just need to solve for the load at the mid-span. Okay, considering that the capacity of the beam is ito, 253. So, ano yung gagawin natin dyan? So, to solve for the load P very easily, you can just equate the maximum moment to the capacity of the beam. Ano ba yung capacity ng beam? Ito, 253. Ano yung maximum moment sa beam? Now, we are given with two common loadings. We have the uniformly distributed load and a concentrated load sa gitna. So, ito yung mga maximum moment ha. So, for a uniformly distributed load, I hope alam nyo, di ba? Ang moment yan is W L squared over 8. Di ba? That's the maximum moment sa gitna. And then, for a concentrated load sa gitna, ang maximum moment din is PL over 4. Okay, wag lang natin kalimutan yung factors, no? 1.2 for dead load and 1.6 for live load. And then you can use your calculator to solve for P, shift solve lang, and then you will get 60.724. Okay, so same pa din. If you have any questions or clarifications, please don't hesitate to comment down below. Maraming salamat sa panonood and thank you for and maraming salamat. Ano yung sasabihin ko? Medyo matagal na kasi ako mag-record. Maraming salamat sa panonood and see you sa next video natin. Salamat.